In this video, we will discuss the properties of numbers, lesson 1.4. The commutative property of addition and multiplication tells us that we are allowed to change the order of the numbers in an addition or multiplication problem to make it easier for us to do mental math so that we can solve the problem more easily. For example, 6 plus 7 plus 3, we might find it easier to do 7 plus 3 first because that equals 10, and then add 6 to that to get 16. Similarly, 4 times 8 times 5, you might find it easier to do 8 times 5 first because that's 40, and then 40 times 4, we know that 4 times 4 is 16, so 40 times 4 would be 160. So we're just rearranging the order of the numbers to make it easier for us to do mental math. The associative property of multiplication or addition or multiplication allows us to change the grouping of numbers as long as the problem is all addition and all multiplication. Notice that they're not mixed addition and multiplication in the same problem. So for example, if we have 4 plus 6 plus 9, in the original problem, we're supposed to do this first. But we might find it easier to do 4 plus 6 first because that's 10, and then add 9 onto that. Since it's all addition, moving the parentheses from here to here will not change this answer to the problem. Similarly, 9 times 2 is 18, and doing 18 times 5 in your head might not be ideal. So you might find it easier to do 9 times 5 first, which is 45, and then doubling that, which is 90. We can usually do that way better in our head than the first way. So I didn't change the answer, I just made it easier to do in my head by moving the parentheses to do a different part of the problem first. Similar to the commutative property, the difference is that this one has parentheses, and we're not actually changing the order of the numbers. If you notice, they still show up in the order 5, then 9, then 2, 5, then 9, then 2. So I didn't actually change the order, I just moved the parentheses, which does change the order of how I solve the problem, but the physical numbers don't move. The next two properties are the identity property of addition and multiplication. What this does is keeps the identity of the original value of the problem the same. So for addition, the way I do that is by adding 0 to get the result back that I started with. And for multiplication, I do that by multiplying by 1 to end with what I started with. So adding 0 results in the same number that you started with, and multiplying by 1 results in the number that you started with. The multiplication property of 0 very simply states that when you multiply something by 0, it equals 0. And finally, the inverse properties of both addition and multiplication are telling you what would you add to a number to essentially cancel it out to equal 0. So that would be adding the opposite. So 5 plus negative 5 is 0, or reversing negative 5 plus 5 is 0. For multiplication, we want to know what would I multiply by a number to get it to cancel out, which in multiplication should equal 1. So this would be a times 1 over a, or for an actual example with numbers, 3 times 1 over 3. We know that when we multiply fractions, we put a 1 underneath, and you can see you would end up with 3 over 3, which is 1. Pause the video and take a moment to see if you can identify which property is being shown. The first one is the associative property of multiplication, because we are not changing the order but changing the grouping. The second one is the identity property of multiplication, The third one is the identity property of addition. The next one is the multiplication property of 0. The next two are both the inverse properties, so this is the inverse property of addition and inverse property of multiplication. And lastly, for the tricky one, this one is actually the commutative property of addition, not associative. Just because it has parentheses, you might think it's associative, but if you look at the actual order of the problem, what I did was I rearranged the order of the problem, not the groupings. The groupings stayed the same. X plus P is still X plus P, and R plus T is still R plus T. Oftentimes, if we are given a statement, we are asked to identify whether it's true or false, and if it is false, we will be asked for what is called a counterexample, which is just simply an example that proves that that statement is false. So for example, the product of two odd numbers is always even. We can see that by giving an example to show that 3 times 3 is 9. 9 is obviously not even, so that proves that that is a false statement. Take a moment to decide if this is true or false, and if it is false, give a counterexample. We know that only addition and multiplication are commutative, so subtraction is not, so that's false. We can show the example by saying that 4 minus 3 is not the same as 3 minus 4. This would be 1, and this would be negative 1. And then the second one says the sum of an odd and even number is always even, and that is also false. So 3 plus 4 equals 7. That's odd, so that proves that that's a false statement.